Okay, so you just saw the video, which was the electrolysis of water. So breaking water into hydrogen gas and into oxygen. So here we have the total reaction. And I want you to look at the two half reactions. So we have 2H2O plus 2 electrons breaks down into H2 plus 2OH. And the oxidation is 2H2O breaking down into O2 plus 4H plus 4 electrons. The voltage is negative for both of them, so notice we have a negative voltage. That is going to mean that this is non-spontaneous and this is electrolysis. We don't just have water breaking into hydrogen and oxygen gas on its own. Okay, we had to apply the battery, which we saw there in the video. Okay, so you may need to pause so you can write that stuff down. The setup will be very similar to our last example with some minor differences. Water does not carry a charge well, so an electrolyte is added to the water. In the video, they used baking soda. Here, they suggest vinegar could also be used. To collect the hydrogen and oxygen gases, we put inverted test tubes are added, shown in the diagram below. Okay, so here we have our beautiful little diagram. We're going to talk about a couple things that are happening here. Electrons are produced in the battery at the anode. So right here we have our electrons being produced. Here they show some sort of wire that's connecting them. In our video we just had a tack, right? Okay, the electrons leave the electrochemical cell through the external circuit or through the tack. They go this way. Okay, the negative electrons create a negative electrode in the electrolytic cell, which causes the reduction of water. So the end of that tack right there caused the reduction of water. Here's the reduction of water, and this is negative. Okay, so notice in an electrolytic cell, our cathode is negative. We don't like cats in electrolytic cell. Note that the area around this electrode is going to be slightly basic as OH ions are produced. So we have a bunch of OHs, so that's going to mean it's basic. So kind of tying to the acid and base stuff we learned last unit. Meanwhile, the positive electrode is releasing hydrogens. So what's going to happen there? That's an assignment question. Okay. Um, there's oxidation happening there. It's positive. The anode is positive. We like onions. Okay. Electrons produced during this oxidation process are then going to return back to the electrochemical cell, to the cathode there. Okay? Finally, the main application of why we do this is something called electroplating. Okay, electroplating is a technique in which a thin layer of a desired metal is used to coat or plate another object. This process is often used to protect objects against corrosion or to improve their appearance. For our example, we will examine the silver plating of flatware, so like a fork or a spoon. In example, we're going to use a fork made with an inexpensive metal, but we're going to coat it with silver. As with our other electrolytic cells, we have three requirements. We need an electrolytic solution, something that will conduct electricity, so there needs to be ions. We will use NaGNO3, which gives us our required Ag, our required silver. NO3, remember, is one of those fabulous things that is soluble with everything. A source of current, we're going to need a battery, and we're going to need two electrodes. One of our electrodes will be the object to be coated, the fork, while the other must be of the plating material, a bar of silver. Okay, so let's talk about what's happening here. We need to have silver ions that was in solution go to solid silver. Okay, this has an oxidation number of 0. This has +1. So in order to get to 0, we need to add an electron. So what's going on here is this is reduction. So this is our cathode. Okay. Then we're going to have that solid silver bar. needs to keep making silver ions in the solution so that then they can go onto the fork. And so we went from 0 to +1, so we needed to lose an electron. So this is our anode and its oxidation. Here is the overall plan of action. We want solid silver to be deposited on the fork. Thus, the fork must be the cathode or the site of reduction. That's what we just showed. Positive silver ions from the electrolytic solution are going to be attracted to the negative electrode, causing the deposition of solid silver. Silver ions will come from the electrolytic solution. As they get used up, they will need to be replaced. That is why we're doing this right here. This is how they're going to be replaced. The final concern is to account for the flow of electrons. Remember, our electrolytic cell will be hooked up to a battery, which is a set of electrochemical cells or other source of current. Electrons will leave the negative post of the battery. So here I have it drawn. Electrons are leaving the negative post of the battery. They go this way. Okay. These electrons will travel through the external circuit to the cathode of the electrolytic cell, our fork. So here's the cathode, it's negative. Okay. The anode of the electrolytic cell produces more ions or more electrons as it undergoes oxidation. These electrons return back to the current. So there we have our flow of electrons. So this is an example of a very good labeled electrolytic cell. And your assignment gets you to do questions just like this, where you do a nice labeled diagram. Okay?